Hello and welcome to the video lecture series brought to you by St. Andrews Institute of Technology and Management. My name is Ravinder. I am an assistant professor with the DCE department, and we are discussing the subject called Advanced Data Structures or Data Structures 2, as you know it. And today we are going to start a new sorting algorithm called radix sort. Now, before understanding sort, we have a prerequisite. That is, we must know the concept of counting sort. At least now you can use many other kind of sortings for you which can be used in the radix sort, but normally we use counting sort because it is most efficient and its time complexity is almost linear. If you use any other counting if you use any other kind of sort inside the radix sort, then its time complexity is going to be increased exponentially. So it is advisable that while implementing the radix sort, you must use counting sort as in helping, let's say, function. So in today's lecture, I'm going to complete or to make you people understand what is counting sort, and tomorrow we are going to continue with the radix sort, in which you will see the a huge application of counting sort. Now radix sort is basically nothing. It's just a three-step counting sort actually. Okay, radix sort is nothing but a three-step counting sort, and that's why we are going to lay our stress on understanding the counting sort more. And tomorrow we're going to just you will go we're going to discuss the radix sort, and tomorrow this lecture will be much easier for you if you able to understand what the counting sort is. So let's get ahead with counting sort. Now here you can see that suppose this is the array that we want to sort. Now counting sort is mostly applied for the arrays in which the maximum or the minimum values lay in a smaller range, that is 1 to, let's say, 100 or so. Okay, because as you will see and you will understand by yourself that why I'm saying so, because counting sort applies a kind of technique in which we don't compare the values, but we actually use the counting of the values or the distinct counting of the values. That is why uh, using very large values or the array having very large values will can be sorted by the use of counting sort, but the memory management will not be there. The efficiency in memory management or the optimal memory management will not be there, and in that case, you can use all any other sorting algorithms available. Okay, so let's say we have an array called A, and we have to sort this array, and we have all the kind of elements in here ranging from 0 to 7. As you can see, the maximum value in here in this particular array is 7. Okay, so I will declare a variable called k, and its value is equal to 7, as you can see. So value of k is 7. Now number of elements in this array A is actually 17. As you can see, the index range from 0 to 16, so the number of elements is equal to 17. So n has a value of 17. So when you start to write the algorithm for counting sort, first you have to find out how many number of elements are there in the array. That could be done easily by using just a simple length function or the len function in Python. Then you have to find out the maximum value inside the array. That you can do by just using the simple one pass of bubble sort. Okay, by just using one pass of bubble sort, you can easily calculate the maximum value in this array. Okay, now the next step is we are going to initialize another array which I have named as count. Okay, now this count will have the total length equal to k equal to 7. Okay, So you can say that length of count is equal to, let's say, k. Okay, or I would say k plus 1 in this case. Okay, or instead of this, would be beneficial if I write something like last index of count will be equal to k. Okay, so last index of last index of count will be equal to k. So count will have a total length of k plus 1, because to have last index equal to k, that is 7 here, as you can see the value of k is 7. The total number of elements in the array in array count will be from 0 to 7, that is 7 plus 1, 8 elements. So we have 1, 0, 1, 2, 3 and 4, 5, 6, 7, that is total of 8 elements. Okay, now how we are going to use this particular array in this case? The count is going to hold the actual number of each element, that is how many times an element has been encountered in the array A. So I am saying that, let's take this first element 1. So I am going to count how many times it has occurred in our array A. So 1 is encountered at index 0, at index 3rd, 5th, 6th, and at index 16th. So number of time 1 has occurred in the array A is 1, 2, 3, 4, and 5. Okay, so I'll write 5 here. Okay, I think you must have understood until now what I have done here. So next is, we go to the next element. I'll first remove this. This is not actually what I'm trying to do. Okay, this is just for understanding. So we'll start the procedure. For starting the procedure, as we know that the maximum value in this array is equal to 7. Okay, and we have a maximum index of 7. So this index will now indicate the value in array A, and at this index, the value at this index in the count array will actually tell us how many number of time that value in A has occurred. Okay, again we have counted that 1 has been encountered 5 times in the array A. So first we'll go to the index 1 of count. Okay, so 1 is signifying the value in A. So 1 has encountered 5 times in array. So I think you must have understood what I am trying to say here. Now the first element of the first index of count 0. Now first index will always be 0. So let's look out for if there is any 0 in this particular array. Yes, we have 0 1 time, 2 time, and 3 time, and 4 time. Okay, so I'll write 5 here, 4 here, and so on. Okay, but this is not actually how you are going to do it when you are going to code it. So how we are actually going to do this? You don't have to apply too much thought into it. It's actually quite very simple. Let me tell you the code first. Now this is the code for this first step. I will start with the very first element of the A array, that is capital A, and for every element of that array that I have encountered, that is AI, which is actually the index of count array, I will update its value. Okay, so initially, let me first erase these values. Okay, so initially what I will do is I will update all the values in this array as 0. Okay, so initially we will initialize all the elements in the count array equal to 0. And as we go on from one element to another element in the array A, the value of the element is actually the index of count, and at that index I'm going to increment the value. Okay, so let's start. As you can see here, the for loop will start from 0th index in the A array. Okay, so at A0 I have a value 1. Okay, and so the count, as you can see here, A0 has actually value 1, so we'll have 1 here. So count at index 1 will be incremented by 1. Okay, so I think you are getting it right now. So count of 1 will be incremented by 1, so this value will now be 1. Okay, so I think you have got the idea. Next, at next index we have the value 0 in the A array. Now at count of 0 we are going to increment the value by 1, that is 1. Next, at index 2 of array A we have a value 2, so count of 2, which is this place, will be incremented by 1, so increment by 1. Next, at next index we have, that is A equal to third. This is the value of I which is going on. Okay, so this is the value of I say A0, A1, A2, A3, A4, A5, A6, A7, A7. So what is being there, that is A, the value at the 0th index of A will become the index of count array, and inside that index the value will be incremented by 1. So this is what we are doing here. So I think we have reached at this point. So now A third will have a value of 1, which is actually index of count. So at count 1 we have to increment the value by 1. Now this will become 2. Okay, so next A4 will have 0, so 0 will be incremented by 1. Next A5 will have 1, so count 1 will be incremented by 1, so this will become 3. Next A6 has value 1, again this will be incremented by 1. Now A7 has value 5, so I'll go to count 5 and its value will be incremented by 1. Now A8 has value 6, so count 6 will be incremented by 1. A9 has value of 7, so count 7 will be incremented by 1. A10 has a value of 5, so count 5 will be incremented by 1. A11 have a value of 4, so count 4 will have an increment value of 1. A12 have a value of 2, so count 2 will be incremented by 1. Again A13 have a value of 2, again count 2 will be incremented by 1. Now A14 will have a value of 0, so count 0 will be incremented by 1. A15 has also 0, so count 0 will again be incremented by 1. And in the end A16 has a value of 1, so count 1 will be incremented by 1. Okay, so in that way, by just implementing this small loop here, quite easy, we have actually counted how many number of time each element has occurred or been encountered in the array A, and that values are actually stored in count array. So this is your first step of counting sort. I think it's quite easy to implement. It looks quite heavy, but it's quite easy to implement in while coding. Okay, so let's move on to the next point. Now in actual array, when this array will be sorted out, you will see that you will see values like all the zeros at the beginning, like 0 and then 0 and then 0. We have 4 0, I think, yes, and then 5 ones, then 1, then 1, then 1, then 1, then 1. I think this is how our sorted array must look like. This is how our A array must look at after the implementation of the sorting algorithm. Okay. Now, to now we know that how many number of zeros must be printed in unison, that is continuously. That is, 4 zeros must be printed or must be stored continuously, 5 ones must be stored continuously, 3 twos must be stored continuously. But we don't know from where to start and where to start. Actually, I know we know where to end because we have the total number of zeros to be stored continuously. So if I start by from 10, then 40 will be 0 at 10th place, at 11th place, 12th place, and 13th place. But we still have to find out at from which index we have to begin storing the new value in a array. Okay, so again I will initialize a new array called new count. Okay, so in this, all we have to do is we have to find out the starting index of the value from where all the, let's say, we want to print all the twos, that is we have 3 twos together. So in this particular new count, the value at index 2, that is at this place, that is the value at new count index 2 will be the starting index in A array. Okay, or we can say in this B array. Okay. So I think you have got the point. What I'm trying to say is, let's suppose we have, let's say the case of 1. So I know we have 5 ones in this array A, and I also know that all of them should occur continuously one after one when we have completed the sorting algorithm. And I know that there must be 5 ones continuous, but I don't know the starting index. So in new count array, add the index 1, which signifies the value 1 in A, will hold the value of the index from which you must store continuous 5 ones. Okay, that is uh, the value here must be 4, because from the fourth index, let's say this B is okay. I will introduce B here now because it's good. It's, let's suppose we're not going to create confusion here. I have also created a new array called B, which is of same length as A, but it is empty now. I have just written here, but I will erase them now. It is empty here. So what I am trying to say here is the new count 1 equal to 4 signifies that at the array B at the index 4, we have to start storing the value 1, and total number of ones which will be stored will be equal to 5. Okay, when I do this step by step, it will get more clear what I am trying to say here. So in this, all we have to do is, also let me again erase this. See, this algorithm is not complicated, but the way the resources I have is making it somewhat complicated. But if you try to focus on the code itself, you will get that it is quite easy to implement. It's quite small algorithm to implement. Okay, so let's move ahead. So first thing first, in the new count, the first value of the count and new count will be same. So I'll write 4 here. So in that case, the first at the 0th index, the value at the 0th index of count and the value at the 0th index of new count will be same. And the next value here will be actually the present value in the count plus its previous value. So the value of new count equal to 1 is equal to count, or the new count 4, or the count 4, or the count 0 plus count 1. Okay, so 4 plus 5 now here is 9. Okay, I think you have got the point here, what I am trying to say. Now, for new count 2, we will have the new count 1 plus count 2. So 9 plus 3 is actually 12. So you can see I have implemented that. I must correct that also. So it must be count here. Okay, I think you have got the point. So let's copy this. So first, let's see that. Let me copy this here. It would be more clear what I am trying to do here. So I can do. It's getting. Paste it. Yeah. Now it would be more clear to. So this will initialize a for loop which will count from 1 to k, because the first element will be same as count element. So initial value of I will be 1. So new count 1 is equal to count 1, that is 5, plus new count 1 minus 1, that is 0. What's the value of I here? That is 1 in first iteration. Okay. So new count 0. What is the value of new count 0? 4. Oh, sorry. 4. So 4 plus 5 is equal to 9. Now for I equal to 2, that is new count at index 2, which is actually this value. The value will be calculated as count at 2, which is value 3, plus new count I minus 1, that is 2 minus 1, that is 1. So 3 plus 9 will be equal to 12. So this is how this particular index will be, the values in the new count array will be updated. So let's move ahead to the 3. For 3, we have count at 3, which is equal to 0, plus new count I minus 1. 3 minus 1 is 2, is 12. So 12 plus 0 is equal to 12 itself. For new count 4, that is I equal to 4. The value of count I, that is count 4, is equal to 1, plus I minus 1, that is 4 minus 1, 3. New count 3 is 12. So 12 plus 1 is 13. Okay. And similarly, we have 15. And we have 16. And I think we have 17 in there. You can calculate the rest, I think. It's quite easy. So I think you have got the point what I'm trying to do here. Okay, now we are at the last step. And in the last step, all we have to do is, we have got the starting index, we have got which value we have to store. Okay, now we just have to arrange these values here in this array B, and this array B can at the end can be copied to the array A element by element, and in that case the array will be sorted. So how we are going to do that? I am going to initialize a loop. So let's again copy this. Let's go first, untab this. So let me again copy this, and I'll show you step by step what I'm trying to say. Okay. So as you can see, I have initialized a for loop with a variable I, which is actually starting from a dot length minus 1. Now what is the length of a? That is 17. Minus 1 is 16. So initial value of I will be 16. And the loop will go on until the value of I becomes negative. And in each iteration, value of I will be decremented by 1. So initially, the value of I will be 16. Okay. Now we have to fill this B. Let me tell you. Okay, I have to fill this B here. This B will actually be sorted form of array A. Okay, either you can rename this as B as A, in some languages it is not method, or what you can do, you can copy after sorting, you can copy this B as it is into A. Okay, so for filling out B, what I'll do is I have initialized, I have assigned the value AI to this index of B, that is minus minus, that is decrement, pre-decrement, new count AI. So I'll tell you what have actually done here. We'll start with value AI first. This value here, AI. Now what is AI? The value of I in this loop first iteration is actually 16. So at 16 we have value 1. Okay. So what is the new count at index AI? So new count at index AI here is this 9. Okay. So what is the A? Let me write it again. So what is the value of AI? A value at AI. Let me write it. At first iteration, I has a value equal to 16. Okay. Now the value at AI is actually 1. As you can see here, it is 1. Okay. Now if I write new count, and the index I will pass is actually AI itself. What is the value of AI? 1. So new count 1. What is the value of new count 1? Is actually 9. So actually 9. Okay. Now this minus minus will decrement it first. So minus minus new count and A, sorry, I is now actually equal to 8. Okay, okay, you can see that. Okay, minus minus new count AI now equal to 8. So I will write here is B, forget about that, not just B, or capital B equal to AI. Yeah, you can see there. So what is inside this? Actually inside this we have actually 8. And this is what we have calculated as seconds ago. It has been removed by here from the Excel somehow. So what is, whatever be at the AI, that is A16, is now copied to B8th position. Now what is at AI? A16, that is 1. It will be copied to 1. And also I have decremented the value of this. Okay, the value of new count AI minus is decremented actually. So instead of 9, we now here is 8. So this is how it will go on. I think you have understood what I'm trying to do here. Okay, so in the, let me do it one more time. So next value of I will be, after the value of decrementation of I will be equal to 15. So for 15, AI is actually, that is A15, we have value 0. So we have 0. And in the new count array, new count of AI, that is new count 0, has actually 4. So we have 4 here. So I will remove this. So if I write minus minus new count and it's AI, then this will actually first decrement the value 4 by 1, that is equal to 3 here. So I'll decrement it. So okay, I think you have got the idea. Don't worry about this. Just move it. Just creating problems for. So what value will be here is 3. Now at B3 we have the value AI, that is A15. Okay, so here I will write 0. And this will go on until I have gone through each element of array A. Okay, so at A14 I have value 0, so I will go to new count. At new count 0 I have value 3. This 3 first will be decremented by 1, that is it will become 2, and at the 2th index of B I will store 0. So this is actually what is happening here. Okay, so in the end your array will look, again let me do step by step. At A13 now we have value 2, so at new count 2 we have value 12. I will first decrement it by 1, so it will become 11. So now B11 I will store the value of AI, that is equal to 2. So it is 2 here. Now at A12 we have value 2. At new count 2 I will first decrement it by 1, that is it will become 10. At A10 I will store the value 2 again. Next we have encountered A11. A11 has value 4, so at new count 4th index we have the value 13. I will first decrement it by 1, that it will become 12 now. So at B12 I will store the value AI, which is actually 4. So I will write 4 here. Okay, and so this will go on. So at A10 we have value 5, and at new count 5 we have value 15. I will decrement it, it will become 14. So at A14 we have to store the value 5. Okay, and now at A9 we have value 7. New count 7 I have value 17. I will first decrement it, and now at B16 we have value 7. Okay, next at A8 we have value 6. So at new count 6 we have value 16. I will decrement it by 1, it will become 15. And this 15, at B15 I have to store the value 6, that is the value of AI in the present iteration. Okay, next at value A7 I have value 5. So new count 7 again, sorry, new count 5 has again the value 14. I will decrement it by 1, that is 13. So B13 will store the value 5. So it will go on. At A6 we have value 1. So at new count 1 I will decrement it by 1. It will become 7, and at B7 I will store 1. And again at A5 I have value 1. And so at new count 1 I will decrement it by 1, that is 6. So at B6 I will store the value 1. Okay, and I think I have reached, yes, A4 I have value 0. So new count 0 will have value 2. Now this 2 will be decremented by 1. B1 will store value 0, 0. And A3 will have value 1, have a value of 1. So new count 1, at new count 1 we have value 6. I will decrement it by 1 first. So at B5 we have to store the value 1. So B5 I have to store the value 1. Okay, next at A2 I have value 2. So new count 2 has value of 10. First I will decrement it by 1, that is 9. At B9 I will store the value 2. Okay, now at A1 I have value 0. At new count 0 I have value 1. I will decrement it, it will become 0. And at B0 I have to store the value 0. And last, at the last iteration of the loop, that is at A0 I have value 1, in the new count 1 I have value 5. First I will decrement it will become 4, and B, your 1 will be stored. So now this array is actually the sorted form of array A. And as you can see in the new count, you can look out for the starting index of each of the value. So the 0 has actually started from the 0th value, 1 has started from the 4th value, as you can see here. So all you have to do now is copy this B into A, and your A will be sorted out. So I think you have understood the complete procedure of this algorithm, that is counting sort. These are the few main steps here, all the 3 steps here. As you can see, it's quite a small algorithm to implement actually, and quite easy. It looks quite difficult, but actually in implemented it's quite easy. So tomorrow we'll see the application of counting sort in the Redis sort.